Welcome to Module 4, Lesson 2. So we're going to dive more into that area, finding how to find the area, and comparing areas to others. So if you remember right, math is a very interesting thing because you can have the same answer by finding different methods. Like one group of 12 equals 12, but you can also do two groups of 6 that will also equal 12. And also 6 groups of 2 and 12 groups of 1. You get the idea on that with commutative property. So with area is a unique thing as well, is that just because the shapes look different, they actually can't have the same area. Sometimes they have the different area as well, just like any problem, but it's possible for them to have the same area, which means they cover the same amount of space, even though they look different. So I'll give you an example of this. And I have a couple of these already created for you, but first, let's go ahead and talk about what our goal is. I can decompose and recompose shapes to compare areas. So I have 1, 2, 3, 4 shapes here. They're all rectangular in nature, but all of these rectangles look a little bit different. So let's just go ahead and find the area of these. Remember, the area is in square units. So these are our units. It's how many of those squares we see. So let's go ahead and, once again, there's two ways of solving this. You can just go ahead and count up all the squares, going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Or you can solve this like it's an array. You can say there's two groups here, there's 6 at the top, so 12. And so for this one, I have 12. This has a area of 12 square units, because there's 12 of these squares, little teeny tiny units. So this one has 12 square units. Now let's look down here at this one. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 going down this way, and it's only one wide, so 12 groups of 1 would be 12 as well. Now look at that. A little bit different, isn't it? But look, it still has 12 as an answer here. This one over here has 12 square units. This one here has 12 square units. So, first of all, are they the same shape? No, they're not. They're different shapes entirely. This one is a little bit wide and a little bit thick. This one is super tall and really, really skinny. But they both have 12. And so the real question here is, does that mean every single one we're ever going to do is going to have 12? So let's go ahead and solve these other two real quick, and then we'll kind of compare. So let's look at this one. Same thing. You can add them up one at a time, or to speed up the process, you can do like it's an array. There's 1, 2, 3 here, and 1, 2, 3, 4, 5, 6, 7. Skip count by 3 7 times, or skip count by 7 3 times, commutative. So I'll do 7, just make it a little faster, going 7, 14, 21. So the area is 21 square units. Alright, so does it look different? Yes, it does. Does it have the same answer as these other two? No. Alright, so we can't always just assume that the area will always be the same, because these two have the same, but this one doesn't. Let's see about this other one. So we're going to go 1, 2, 3, 1, 2, 3, 4 here, and there's 1, 2, 3, 4, 5 across. I know my 5s very well, so I'm going to skip count by 5 4 times. 5, 10, 15, 20. Alright, so the area for this one is 20. So once again, we're getting different numbers here. So why is that the case? What's going on here? Why are these two the same, but these two aren't? And it comes down to, well, how many units is it made out of? This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in it. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I'm going to do something here. A little tricky to do here on a whiteboard, but I'm going to do something and imagine what I'm going to do. So I'm going to count down 6. 1, 2, 3, 4, 5, 6. I'm going to cut it in half right there. Now I have 1, 2, 3, 4, 5, 6 down here. Now I'm going to take this 6, going to take it off, and I'm going to put it right next to this one up here. So I'm going to move it right next to this spot right there. So we're going to erase it because it's being represented somewhere else now. Now, did I change the number of squares? No, it's the same amount. I just rearranged them in a way. Instead of having it super long, I just took the bottom 6, put them next to the side. Just keep that in mind. Now this is a 6 by 2. Wait, commutative property. 2 times 6 and 6 times 2 is the same thing, right? Yeah, it is. So even though that they're rearranged differently, as long as they still have 12 square units in it, they have the same area. One can be very long, one can be very long and very skinny, one can be very tall and very skinny, one can be in the middle, a little tall and really wide. Just kind of keep in mind. Now, the other two here is 21 and 20. So, same rule going on here. This doesn't have the same amount of squares over here. And there's no way you can rearrange this to make it the exact same as this without taking stuff away. I'm at 21, which means to get to 12, I need to lose 9, which means I have to get rid of 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, let's look at that for a second. If I were to cross out all of these ones right here, now 1, 2, 3, 4, 5, 6, 7, 8, 9, look at the remaining ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this one has 1, 2, 3, 4, 5, 6, 7, 8, 9 more than these other ones. And you can rearrange those in a different shape, and it's always going to be 9 more square units than over here. That's interesting. We're going to go ahead and erase those up a little bit. And you can actually determine which one of these is larger by Xing things out, kind of like I did. If I wanted to find the one that's largest, well, you can just look at the larger number. The one that has the more units is the one that has a larger area. But for kicks and giggles, we can go ahead and do that. And you could basically take one away from each of these, and the last one standing is the one that has the most. So I could take one away from here, one from there, one from there, one from there, and just keep doing this to determine which one would be the last one standing. So I'm just going to kind of do one mark just to speed this up a little bit, but you get the same idea. Oh my goodness, if you are noticing something here, I am getting close to running out of these two over here already. I'm just going to keep going. I'm going to speed up and make sure I am not making a mistake, because if I make a mistake, it kind of ruins the point of this. Oh, look at that. But I think I already marked that one. How many marks have we done? So 11, 2, 3, 4, 5, and 11. Okay, there we go. Just making sure I'm double checking my work, because you need to do that. And I don't have any more to do with these ones, so these ones are gone. They're out. I'm empty. Which means if I've taken away 12 from all of these, we've already figured it out. This one's 9 more, so there should be 9 more left. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're accurate on that one. And 20 is 8 more than this one, so there should be 8 left. 1, 2, 3, 4, 5, 6. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I'm struggling with my counting today. And so going on that, if you were to continue on, you'd find out that as you did this over and over and over, you could find out the one that is largest is the one that has one remaining when all else are out. And that is this one right here. So this would be the largest area. Now, that was kind of going into a little bit depth of showing why its area is larger, is because it has more of those blocks. It's basically saying the number 21 is bigger than the number 20, and the number 12 is smaller than the number 21. Now remember that, because that's kind of the main idea here. If you have an area that is 40 square units is bigger than 30 square units. But in math, 30 bananas and 30 bananas, that's the same amount. I have 30 over here, I have 30 over here. They're the same. So same thing, but it doesn't matter how they're arranged. They could be in the tree or they could be on your table. 30 is 30. Same thing applies here. You can have 30, just one line, one row of 30 going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, all the way up to 30. Or you could have 3 rows with 10 in each row. It looks different, they're organized differently, but it's still 30. Now that's kind of the main idea here, is recognizing that you can't just, very rarely can you just look at an array or to find the answer, because these are kind of like arrays, and just know the answer automatically. You got to look at it. sometimes you may not be able to look at them and be like, oh, these two are the same for sure. Sometimes you actually need to solve them to determine, oh, this one's 10 and this one's 10. Now they're the same. So just kind of going out, double check, recheck, actually compare. Don't just look and be like yes or no. Do the work and then determine if they're the same or not. Because if they both have the same number of square units, they're the same. They're covering the same area. So that's kind of the primary point of this lesson. Hopefully this was helpful, and I hope you guys have a great day.